Find sine of 2x, cosine of 2x, and tangent of 2x from sine of x equals 5 over 13, where x is an angle in quadrant 1. We will need to use the double angle formula for sine, cosines, and tangent. First, we need to know what they are. Sine of 2x is 2 sine of x times cosine of x. Cosine of 2x is cosine squared of x minus sine squared of x, or if we want to, we can use 1 minus 2 times sine squared of x, or 2 times cosine squared of x minus 1. Any of these three versions will work for cosine of 2x. And tangent of 2x is 2 times tangent of x over 1 minus tangent squared of x. Because of these, to evaluate sine, cosine, and tangent of 2x, we will need to know sine of x and cosine of x. But sine of x is given 5 over 13, where x is in the first quadrant. We will use this information to find cosine of x. We will present two different methods to find the remaining trigonometric functions, but you only decide one method that works best for you. Using the trigonometric identity, this is the Pythagorean identity, we have cosine squared x plus sine squared of x equals 1. Given sine, we need to find cosine, so this is the equation or identity that relates the two, knowns and unknowns. We're looking for cosine of x in this case. Cosine squared of x plus sine of x is given 5 over 13, and we isolate cosine squared of x first. This is 1 minus 5 squared is 25, and 13 squared is 169. Cosine squared of x is therefore, the common denominator is 169, so we multiply 169 over 169 to 1 to get 169 minus 25 in the numerator. 169 minus 25 is 144. The denominator is still 169, and this is cosine squared of x. Cosine of x is therefore plus or minus the square root of 144 over 169. This is plus or minus, the numerator is 12 and the denominator is 13. But we were given that x is in the first quadrant, so cosine of x needs to be positive 12 over 13. Alternatively, we can use the right triangle approach to find cosine of x. First, we were given that sine of x is 5 over 13, where x is in the first quadrant. We draw a right triangle with the angle x. Sine is opposite, so the opposite side to x is 5, and over the hypotenuse is 13. We conveniently set the opposite 5 and the hypotenuse 13 because this is the trigonometric ratio. To find the missing side, we use the Pythagorean theorem. We say that 5 squared plus the missing side, which is the adjacent side squared, equal 13 squared. From there, we can isolate the adjacent squared, which is 13 squared minus 5 squared. And so this is 169 minus 25, or 144. The adjacent side is therefore the square root of 144, which is 12. Regardless, we found the adjacent side to x, and it is 12. Using the trigonometric ratio, we have cosine of x is adjacent over hypotenuse, but this should be a plus or minus still. We can determine the sign because x is given in the first quadrant, and so cosine can only be positive in the first quadrant. We don't need the plus or minus. Armed with this information that we just found for cosine of x, we now evaluate sine of 2x, which is 2 sine of x times cosine of x. But sine of x is 5 over 13. Cosine of x is 12 over 13. Multiply across, the denominator is 169 and the numerator is 120. 2 times 5 is 10, 10 times 12 is 120. Next, cosine of 2x is, we have 3 options to choose from for cosine of 2x. Use whichever option that is convenient. Usually, we want to use one that has only one trigonometric expression in it, but if we have both cosine and sine, we can use them too. In this case, since sine of x is given, we're going to use 1 minus 2 sine squared of x for cosine of 2x. Sine of x is 5 over 13, and we need to square this. This is 1 minus 2 times 25 over 169, which is 1 minus 50 over 169. The common denominator is 169. We multiplied 169 over 169 to 1 to get 169 minus 50 and obtain the common denominator. 169 minus 50 is 119, and the denominator is 169. So cosine of 2x is 119 over 169. Next, for tangent of 2x, there is an easier way to compute tangent of 2x, but for now, tangent of 2x is 2 times tangent of x over 1 minus tangent squared of x. So to compute tangent of 2x, we should find tangent of x first. We either use the trigonometric identities or the right triangle. Using the right triangle, tangent is opposite 5 over adjacent 12. So tangent of x is 5 over 12. Remember that x is in the first quadrant, so tangent of x is positive. Tangent of 2x is therefore 2 times tangent of x is 5 over 12 over 1 minus the quantity 5 over 12 squared. 2 times 5 is 10, so the numerator is 10 over 12. The denominator is 1 minus 25 over 144. The common denominator in the denominator is 144. We multiply 144 over 144 to 1 to get 144 minus 25 in the numerator of the denominator, and now we have 144 as the common denominator. In the numerator, 10 over 12 is simplified to 5 over 6. This is the complex number, so we will need to simplify this further. 5 over 6 in the numerator. 144 minus 25 is 119. So the denominator is 119 over 144. This is 5 over 6 times 144 over 119, because dividing a fraction is the same as multiplying the reciprocal. 5 times 144 is 720. 6 times 119 is 714. We can simplify this further by reduce the fraction. 720 over 714 is 120 over 119. Now, we didn't really have to do that for tangent of 2x, because remember that tangent of 2x is sine of 2x over cosine of 2x, but we found sine of 2x. Sine of 2x we found earlier, it was 120 over 169, and cosine of 2x, it was 119 over 169. Simplifying this, tangent of 2x is 120 over 119, and we could have been done with the problem.